Hello everyone. At the beginning of the presentation, thank you everyone for joining this webinar. I hope that it's not too technical, but I think it's something which we really spent quite some time on this idea of how can we make services easier to identify and understand. First of all, I show again this slide of the previous and ongoing webinars in our series. The next one will be again an more application oriented webinar on our case studies, or the next two, and then we have a more technical again, and then we will go on with the case studies. Therefore, please also look at the previous case study presentations or the technical as well to see what OpenRiskNet did when you didn't already do that. All the webinars are available, therefore please go ahead and look at them. The same as with this one. This is also recorded and you can check what will be, or if you want to check again what the specific topics, please go ahead and visit our website. As I said, today we concentrate on semantic annotation, how OpenRiskNet is trying to do that with services, and especially also the functionality of these services. How can that be made more computer accessible, that other services can understand that, but also both the human user, but also workflows which are based on that to make functionality more automatic, accessible. I will give first a short introduction to what OpenRiskNet is for the people who don't know that, but very concentrating on this topic of semantic annotation. Then I will discuss a little bit on ontology and RDF, depending on what a question which I will ask, or three questions will to you will give. I can do that a little bit longer or shorter. And then we will go into the three goals we have in OpenRiskNet for this annotation. The first one is making services known, what they can, and describe the capacities in more detail. And at the end, having the third goal is to improve steadily and improve on the metadata which is available for these services, and having this metadata in an annotated form. OpenRiskNet is our infrastructure project, really case-driven. Therefore, we have these many case webinars on our case studies for chemical and nanomaterial risk assessment. We are integrating tools. We are not developing new tools, but we integrate them from existing research projects. Therefore, we are this infrastructure project, and having in that way making this integration of different data, but then also modeling tools easier available to the users. And to show that this is really the case, that we are helpful, we want to include the stakeholders as soon as possible, and this we do, for example, in these webinars. Case studies are taken from risk assessment frameworks. For example, here, this was something which came out from CIRIT, and we transferred that, but this is the part I don't want to talk too much about, because this is in the other webinars. I want to go more in the technological developments we are doing, and the main thing is in OpenRiskNet is that everything is based on REST services, which are described or which provide APIs which we harmonize in a way. And the harmonization is mainly in the semantic interoperability layer. And the services have something which is understandable by the OpenRiskNet infrastructure, that this is an OpenRiskNet service. And with that comes some kind of features, how to understand this service or how to find this service and how to integrate data. The other things are then containerization of the services, these virtual infrastructures where then these services are running on. Also, these two things are part of an existing webinar and of upcoming webinars. Therefore, I also go not into details here. But what is now this semantic interoperability layer? What do we want to get from that? And the first thing is, many times it's complicated to find what type of services, of modeling services or data is available for a specific topic. Therefore, OpenRiskNet tries to build that, tries to build listings and catalogs which provide this information, what is available, and for that to make that easier and more automatic and not having somebody to update that all the time and be on state of the art, this annotation will help in finding these services. This is the first goal we have. The second version of goal is that we want to know what these services are and what you can do with them. And for that, we want, for example, to understand what the data schemas are, which are presented or which are used in databases. We want to know who provided the service and so on, and in that way, get some kind of information on how to use the data, the service, and also how this can be then combined with other services. And this is what input is required for a specific version service, but also what is then coming out to see if that might be the input of another service. And finally, the third and perhaps most complicated thing is, can we also then get additional, or how much additional information we can get attached to this service? Can we get the background on the relevant publication, manual tutorials, easy access to this material, but also having information on, for example, what type of data, what is the data, for what can this data be used? And I will talk about annotation mainly as in an example from what the EPA was doing for ToxCast, to show that with providing this metadata, it's much easier to do fancy things with the services, data services or software services. What we did, and this is the main development in OpenRiskNet, is that we defined how to specify or how to do this semantic annotation. And this is something which is based on existing standards, by combining them and hopefully in this way getting what we need. On the one side, description of the services, on the technical side, the APIs, but then also the scientific annotation. This is done by OpenAPI definitions, plus then forming that as JSON-LD, and I will go into detail into that. But if you want to look at our reports about that, these are also freely available. Here, just as a slide where you can look at, if you really want to go into this topic, we have some kind of, or there are nice tools out there for API definitions, the Swagger editor or the JSON-LD playground, where you can get either play around a little bit with your own things, or also with some standards, which I will also use in this presentation. Good. First, my question to you is, how much do you know about that already? Do I have to go into more detail? How much detail I have to do? Therefore, I have 3 questions, and you are now able to answer one after another, 10 seconds, something like that. You have to be quick because we want not to spend too much time on that. Therefore, please, the first question. Okay. Let's go to the last one. It looks like that many of you have already some experience. It really looks that I don't have to go into too much detail. The slides I will bring that, or I have some slides to describe that. And both APIs and ontologies were more or less 80% or 70% to 80% had already previous knowledge. For the annotation, the real hands-on experience with annotation of things seem to be 50-50. It changes a little bit between yes and no. It's not clearly defined, but I think this is also for understanding that not so important, but then at the end for doing that, and I think it's very interesting to do that at one point of time yourself, because you learn a lot and you see also a lot of problems we have with existing ontologies and how do you use that. Therefore, as I said, we have probably 50-50 who did it already, which is also good, but at least heard about it, open APIs and the ontology concept. It's much more, which is also good. Therefore, I will speed up a little bit this. Okay, semantic annotation as a starting point. This is something which really helps us to define a domain or a conceptualization. Yeah, that we try to understand a specific domain and bring that together. And it is very important, or why this is important, is that we really see in the data that there is a whole one, a huge heterogeneity, and also in our language, yeah, that people understand different terms differently, or they use different terms, which is fine in our normal day-to-day conversation, because we can probably easily get to the point that we understand each other, or we don't understand each other because we use a little bit of different terminology. But if you do that with a computer, it's very hard to understand what is really a synonym and what is a typo, yeah, and these kind of things. Yeah, and therefore, having these ontologies as a part to put that down into a formal mechanism how to do that. This started relatively long time ago, 20 years ago, even more, with the gene ontology, and then 2007, the biomedical area really jumped in and has now this open biomedical ontologies foundry, which is really offering already a lot. But you also see that the toxicology field and risk assessment field is relatively late. Yeah, we still discuss that. We have a lot of open areas where we just don't find the ontologies. But in principle, we can already put our work on a lot of the existing ontologies, and therefore we can catch up hopefully very quickly. Yeah. Taxonomy, just to say, okay, we need a list of defined terms or concepts which we want to use, and this can then look, for example, here, and the nanomapper is definitely one of the, or to my knowledge, most developed toxicology risk assessment ontology. And there you see that you have a lot of these concepts which you can define with specific definitions. The good thing with ontologies is that you have different levels. You can go from the very general knowledge description to very specific application ontologies, and they can reuse each other. We can get to the very basic concept and use ontology terms from there to then specify our specific application. And eNanoMapper is doing exactly that, doing a lot of integration from different ontologies and bringing these concepts in to have our application ontology for for, in this case, nanomaterial, but in principle, I think that eNanoMapper can become much more and become part of a more general risk assessment ontology. The second concept we need to touch a little bit before we can go on is RDF, because we want now to describe facts and or relationships between things, and for that this subject, predicate, object triples are very nice, because you can easily then identify something like Joe has a home page with this identifier, can be easily encoded into this triplet. Let me say subject is Joe, he has a predicate, has an home page, and then we link to this to the home page. And all of these are in principle URLs, which or Is, which can be used to really identify what or have a specific description of that and the definition that everyone can look up and know exactly what it is. And therefore, this is linked back to the ontology concept. You can build very complex graphs with that. This is still very simple. What we do at the end is much more complex. And I think who was in the meeting with given by Marvin, he showed that, for example, for the wiki pathways and AOP wiki, which you saw very much more complex things. What we are now doing is, or what OpenRiskNet is doing, is now using JSON-LD to represent these triples. And in principle, the good thing is that this is more or less standard JSON. The only thing is that on top of that, this semantic annotation is coming in, and this is mainly done by these contexts. And here in this example, it's also a relatively simple example. We just say all the contexts which we need, these ontology contexts, we just name from, take from schema.org. Therefore, this is very simple. You can just define that, and then you get already this triples. And then you say, okay, person John Doe has a name. Therefore, we know that this type is a person, and this is already then annotated with a schema.org. The same as for name, job title, and so on. All these things are more or less defined in schema.org, and then we don't have really to think about it. In our case, since we are using more chemical related or biological related things, we have to collect that from the different ontologies, and I will show that in a second how that works. Just going back to Swagger and OpenAPIs, because we now have this combination. This is just an example of one of our APIs we have. Here you see that how this is described. Since many of you already know that, I would jump very quickly over that. But just to say, if you don't know about APIs, then have a look at one of these specifications, because there you can nicely explore what a service is doing. This is just the JSON format of this whole thing, because now we start annotating that. We have different fields. This is a data set, which I will use in the follow. But here you also see now how this JSON-LD is coming in. Because we have on the one side this context where we can define all these ontology terms. That we say, okay, we don't have now one specific ontology which covers everything, but we have to now get all these terms from different ontologies. And then, but then we also have these types and IDs where we can say, okay, here, these are the objects and subjects, which we define by these IDs and types. And these are the predicates, which then say what that type is, or how the relationship between one of these objects and the other is. I think just to summarize a little bit why I gave this relatively long introduction, why do we want to use that in OpenRiskNet? And in principle, this is the same as why ontologies are used, because we really need to make sure that something which is semantically identical is also seen as that. because as I said, people use different synonyms, people mistype things. If you have a reference to an ontology term, you know that this is really the same, as long as the user or the people who annotated the data didn't do any mistake. But I think I don't touch that, because that is something we want to definitely have also, is this ontology training, that many people or more people can really annotate things and also see the problems on the existing ontology. But as I said, I don't want to go into detail. But for our purpose now, this subject predicate object implementation, having on the one side ontologies, but then having RDF formats to really build this relationship between subject and object, is the way how we see annotation of OpenRiskNet services working. And on the other side, we have also the advantage to have these different ontologies, or take things from different ontologies, and in that way get a more global coverage of what we want to describe. Good. Second set of question. Now that I gave this, I think the real question is, do we need more training on that? And if yes, would you prefer that as a webinar or as a face-to-face meeting, which we would like to organize as part of OpenRiskNet? Therefore, just give your vote if that is something you are interested in. Okay, this looks like that many people are interested in. 70% of you gave your vote and 90% are in favor of that, and now we can just think about how to do it. The second question. Okay. Good. That is also relatively clear. 50% are for webinars, 50% are for both. That looks like that. At least we should definitely organize a webinar on that. That will also get into touch with Egon and George from Maastricht and Birmingham, which are more expert on that than I am. Therefore, I just gave this very short introduction, and then I leave it to them to organize. To organize more training on that. Good. No, thanks for that. And I was hoping for that, that we can, because I think it's a very important topic, and we need to educate more people on that. Thank you. Good. Now to what we are really doing. That was all starting and giving some feedback or introduction. Now, what do we want to do? And as I said, the first thing is we need to make, or a service, an OpenRiskNet service has to say, hi, I am an OpenRiskNet service. That people can find it, that we can put it onto our catalog easily integrated there, and then people can look at that and get the information. Yeah, there are services which are of interest for a specific application. This I more or less already said. What we have is the service catalog as the first instance or the first entry point where you can look at what is available from OpenRiskNet. And this at the moment includes a lot of the consortium services, but we have now our associated partners which will provide more and more services, and in that way we hope that we can provide more over time, and at one point of time really cover all the areas we want to in risk assessment. That's the general what is available. The other thing is when you have your virtual research infrastructure, and you can use our reference instance at the moment, but you can also put that onto your own computer or for your organization, and then the user wants to know what is really running at the moment. What do I have to install, or I don't have to install because it is already on there. Yeah, and this is done by the discovery service, which really looks what is working, what is running on this virtual research infrastructure, what can be used directly. And the other point is then what we have, the Sparkle query tester, where you can dig then more into the semantic annotations. This is the services we provide, which is using directly the annotation, which is already existing. But in principle, you can then use this in your own application, and I hopefully have the time to show also there a little bit. That is not what I wanted to do. This was just clicking on that, but when you get the slides, you can do that yourself. I wanted to go here. As I said, the first thing is you have to the service has to announce itself, and we wanted to keep that as simple as possible. And for doing that, in principle, you just have to add these two lines here, yeah, in your API definition. That you say, okay, this is what is the ID. Yeah, this is just the link to the website, or not the website, but to the point where you can access the service, and then you specify that the type is a service, yeah, an OpenRiskNet service. And probably you saw this OpenRiskNet things before. In principle, and at the end, this should be all be ontology terms. But for the time being, and we develop this ontology at the moment, really specifying the types of services and so on, you can, but until this is not really existing, you can use this X minus notation, which is standard JSON-LD format, where you say, okay, this should be an ontology term, but there is nothing existing, therefore we just use that. And X also here, this starting point in principle in JSON-LD, this should be only ID or only at type. But the problem then is that this is then not correct JSON or API definitions anymore, because in API definitions, you cannot just add whatever you want to. Therefore, we cannot add ID, but we can add everything which starts with an X minus. And therefore, we just encode that into this X minus OpenRiskNet ID, which can then, can be easily back translated into an ID to have the JSON-LD compliant format. But with X minus, we have an OpenAPI, still a completely valid OpenAPI definition. Therefore, this is this kind of mixture which we have to do. But in principle, this is the only thing which we have to, which is necessary to really be able to combine OpenAPI definitions with JSON. Yes, we can then go into a little bit more detail. Yeah, this was for this whole service. We can now also do that for specific endpoints that we get. For example, here a get, which API endpoint, which just returns a compound, but then you can specify that this is a compound and this is again the path to that, and the method is get. Therefore, you have already a little bit of this more specific things. Point, just to touch that, in principle, this is the annotation. We also have to then, when we develop this into OpenShift, which is the infrastructure which is running then the services, you have to do a little bit more in the specification of these. It's also not so much you only have to annotate here or put in these annotations, but that again is something which we cover more in detail into another webinar given by Tim in early June. Result of that is that we can have these listings. This is what we have on our OpenRiskNet service catalog. We can now use this information which is not completely integrated yet in this form, but can be built on top of that. What is already running is this virtual research environment-based or service discovery, where really on a running virtual environment, you can see what is going on there. Good, but that is the starting point. Now we know that there is something interesting out there. Now we have to go into what is that exactly. At the moment, we just know this is something which might be of interest. Therefore, we have to go a little bit more into defining what this service can. And at the moment, we do that onto two very different extreme levels. The high level, which is very much, again, going into this area, how to identify what is relevant for me. And on the other side, then when you identify something which is relevant, then to understand better how to use it. Again, this high level, we try to keep as simple as possible. Therefore, we just added a couple of additional things into the OpenAPI definition. Something which is already standard OpenAPI is this operation ID, where we can put in already some annotation, that we say, okay, this is a trained model, for example, a service which provides a trained model. And the starting point, we used here the OpenTox specification, which was a previous project which OpenRiskNet is mainly based on. But a lot of the things we have here are based on the original OpenTox project, which was more specifically looking at QSAR models. But here we have already a couple of things which we can annotate. Yeah, and you can say, okay, it returns a compound, a data set, an algorithm model, whatever. Yeah. On the other side, we can also look at what is needed. Yeah, what do we expect or what does the service expect? Yeah, and in principle, here this is a jackpot example. This expects a list of parameters which are needed to use this modeling service. And what it returns, and one of these parameters is a data set. And what you then get as a return value is the ID to this trained model. And in that way, you have already a little bit of information on what is needed on the one side, and on the other side, what is returned from the service. And this model ID could then be used in a prediction service, for example, based on this model. This is just another example, or my example I will use in the next couple of minutes as well, is this Edelweiss or a ToxCast dataset, which we put into our data management solution. Therefore, we can say, okay, this is an OpenRiskNet service. The operation ID is a dataset, and it returns a more specific specification of this dataset. Yeah, that it's Edelweiss dataset, which we are still thinking about how to define that. What we really want to give back. In this way, we would say, okay, this has a specific format, a specific data schema, which the Edelweiss data solution is using. We could also return that this is a bioassay data set of a specific bioassay as an annotation. And therefore, there are also some kind of discussions ongoing. What is the most important thing you want to know at the moment? But in principle, we can also add here more annotations, and we are not limited to just this one annotation. Okay, what you can do here, and don't be afraid of what I'm showing here, but this is the status where we are. We can now run Sparkle queries against this annotation. If you don't have an idea what Sparkle is, wait until we describe that in another webinar. But in principle, the outcome is the important thing. what I'm looking here is in principle for everything which is an Edelweiss dataset. Sorry, that was too quick. And then I get as a result all the available datasets, Edelweiss datasets, which are running on it. Yeah, I'm asking now this service discovery, what is available, and more specifically, is there anything which is a dataset or a specific Edelweiss dataset available? And at the moment, on this instance, there was only one. This is my playground. And you can now say this is the available service, which is an Edelweiss dataset, and this at the end you can also see then what this exactly is, the title for it specific. That's the high level. I now identified that there is something which I'm interested in, and this is a Edelweiss data schema or Edelweiss data set, but now I want to define a little bit more what this is, what is available in this data set. And we are talking here more or less about tabular data at the moment, but this can definitely also be extended to others. But in principle, we have a set of different entries, a sample ID, which is just more or less a running number. We have information on the substance, the title, and we have activity data. And here's also what this specific assay was. The activity is then a little bit more, but we use here something which is also OpenAPI standard, is these schemas that we can group things together. We can now say the activity is a quantity, which means that this thing has a unit, a value and a unit, and perhaps something like a modifier. But it definitely has a value and a unit. And these two belong together, and this can be done with these schemas. This can be a little bit more complex in saying, okay, our substance has a compound or has a CAS number, has a concentration, but it also has then something which is more related to the compound. And we can discuss also what a substance and a compound is. I'd love to do that, but not now. But this compound has then, for example, a compound ID in PubChem, or a compound name, or an key as well. And in that way, we structure a little bit in the API definitions what we have, what this data set looks like. And in the same way, probably services will structure their output or the input of what is needed as input in a similar. Good, but that was all just APIs. And now we need to think a little bit what we have here. And we have here the substance. I think I can jump over that. Okay. This is just the corresponding data. You see here also there's the structure in there. You have a sample ID. You have then the PubChem compound ID, the compound name, INCHI key, and so on. You have here the concentration, and then you have activity values. And this you have now for many compounds, as much as are in this data set. But now we have to go and understand that better, or annotate that. This is what we want to do here. And therefore, we go in here and say, can we annotate these tags? And we can now really, with this context, in this context, we make this connection to between these tags. Now we can say, okay, what is a compound? And the compound has a very specific ontology term, which we can just assign to that. And then in this way say, okay, this is a compound. Therefore, this object here, which I define here, is a compound, and this is by doing here this annotation as the predicate. Therefore, this is still the predicate. Therefore, we say the substance has a compound. This is the predicate, and this links then to the compound object. And we can do that for many other things. The ID, different IDs, ING keys has a specific ontology term, smiles has a specific ontology term, and so on. We are fighting a little bit at the moment still in how to annotate these things, and in easy data sets, this is relatively simple. But when you become more complex, you might get into things which are just not just defined by one ontology term. And this is not because smiles is not available as an ontology term, but we have a specific meaning of the smiles. And in this case, it was the smiles of the test compound. Yeah, but it might be also a smiles of something else. And here we try to develop more complex ontology terms in the way that we say, okay, we have this combination. For example, I have different IC50 models. I use algorithms to define different IC50 models, but now I want to specify that this is the IC50 which is coming out of a Hill model fitting. Yeah? And perhaps even that it's calculated by this very specific library. And then we can do that we just say, okay, we have for IC50, we have an ontology term in the bioassay ontology. We have also for the Hill model fitting something already in the ontology, in the same ontology, which is nice in this case, but it could be also something different. And now we have to just combine that. Yeah, and there are nice things to do that, but that is also going more into an area which we probably should cover in another webinar, where you just say, okay, I can now take these two ontology terms and combine them to a new one, but which still covers the information you have from the original ones. And therefore, I know that IC50 has a hierarchy. IC50 is somewhere linked into this ontology, and all the information on higher classes will be still remain. And the same thing is that Hill model is a fitting model. Now, also this information remains. But by combining them, we can have an additional information, or we have even more information that this thing we annotate is really an IC50, but based on a very specific model. And the same we can do, for example, with this smiles example I had. You can now annotate smiles, but you also can annotate that this is the test compound, and combining that, you can say this is the smile string of the test compound. Okay, if you have these annotations, now you can build these triples out of that. Yeah, and this is here as the same way as in this easy example, that you say, okay, we have the subjects, which are in our cases more or less not defined. Yeah, they are just instances of something. Yeah, they are not really defined. The more important thing is the predicate. Now, what is this thing, or how is the relationship between this first object and the second object? And then you can build these nice trees out of that. And in our case, it's mainly trees for the data sets. In the wiki, AOP wiki, it was more network, but here we have more trees. And then you can say, okay, the whole data set, this is this first object, includes substances. Therefore, these objects are all substances. These objects have description, but they can also have then properties, and these properties can, for example, be concentrations, and these concentrations have then values and units. But we can also, they also have CAS numbers, and they have more information which we group into these compounds, like INGs and these kind of things. Therefore, this is not the end. Here it would go on, and the whole, if you want to look at the full sub tree, then you can also click here, and then you see a very complex set of trees or set of nodes which are connected. But all these, and this is what you see here, all these are annotated with ontology terms. you can now use that, and this is also something I will jump over very quickly because we are almost running out of time. This is an example I just put in to now extract this information, that you can now query that again with Sparkle to find the important, where is my concentration in this data set? Where is the activity in this data set? And if I know which columns that are, because they are annotated, I can extract this data and then do, for example, my own dose response curve fitting. And in that way, have the only thing I have to define, and this is more or less what I have here, is what am I looking for? I'm looking for the concentration, I'm looking for smile strings, and in that way have the compounds, have the concentration, have the activity. And when I collected all these things, I can run that without having to look at the data set myself, because I just define what I want to find in this data set, and the annotation is giving me the results for it. And I hope that this makes it already a little bit understandable why we do all these things. Third goal, and as I said, I'm really a fan of metadata, therefore I want to know as much as possible about a data set as possible, and that in the easiest way. And I now have what it is. I have a little bit what this data looks like, but I still don't know exactly what this activity is. And therefore I need more data on the data set or on the service to understand what this is used for, or what this data really is. And as I said, we can, or what we already designed, is that every of our services will have, and now we go to the will, have an additional endpoint which provides this additional data, metadata. And many things are relatively easy or straightforward. Who is the provider of the service? This, I think, is a very, very important thing to understand where this is coming from, and perhaps also the quality of the service. We want to have a better description, and this is more an human readable description. We want to understand what we can do, manuals, tutorials, publications, all these things. But if it's not on our virtual research infrastructure at the moment, we also need to know where the containers are or how we can access the service. But I think we should do more, and this is more my long-term view and my hope that we can go in there. And here I just present something, as I already said at the beginning from the EPA, that we can also annotate or come up with some sort of harmonized annotation on data, assays, but also then computational services, which describe the endpoints, and now not the API endpoints, but the toxicology endpoints. What is this used for? What is this model? What does this model predict? And not just by reading a full description of, yes, we modeled this data set, blah, 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 but as a starting point in something which also a computer can read. And I think the EPA did there a great thing already, and if we can transfer that to other points as well. And if you are interested, I really recommend reading this annotation guide. Here, just for this, also very short, I cannot go into details, but just to see what is there as annotation, is really they were thinking about how to define the technology, time points, fingerprints, solvent, a lot of things, a lot of metadata which is already in there. Here, key assays. Then the format, what is it? Is it a cell model? Is it a tissue type? And so on. All that, defining the assay in a way which is also annotated, or available in an ontology, and many things, or most of the things here are also from this bioassay ontology, where you say, okay, at least I can say, I can group all the cell-free assays and look at specific organisms, and don't have to read all the documentation to find out that this is modeling rat cytotoxicity or some, or this doesn't make sense, but I'm not a toxicology, as you see, but just cancer or mutagenicity in rats or something. And then what I also like very much is this target definition, and that you really look here and see what do I want to look at? What are the genes? Is there a gene related to this assay or to this? Probably there we are really talking about data, but can we put that onto a gene, or can we put that and assign an wiki pathway identifier to this target? Is this assay measuring a specific biological pathway, or is that even associated to a key event in an adverse outcome pathway? All these things, and as I said, in a very hopefully much more computer readable and in that way easier to extractable form. Conclusion, and I almost did it on time. I hope that I can show that we are or I show how we worked on this idea of bringing more information into services, into service descriptions. I think the first two goals, we are more or less done with it. We just have to implement it in more and more services. This was the identification of OpenRiskNet services, and then this high level and low level annotation of what this service is doing, what the data looks like, what the input looks like. What we are still a little bit working on is this idea of the additional information. We have to implement this additional API endpoint for the metadata, but then I think, and this is a question to the whole scientific community, is really how can we bring this information in that it can be used downstream. And I think we had very nice webinars on AOPs and key events and biological pathways, and I think this association between data and then these knowledge sources on adverse outcome pathways. I think that is something where semantic annotation can really make a huge difference in how fast we can get, or how fast we can get to this knowledge information and collect that to combine really this knowledge, automatically combine data we always produce all the time to the knowledge which are collected in all these knowledge bases. Acknowledgement is going to all our partners as always, and additionally definitely to the European Union for funding this project. And finally, I just show this slide again to announce the remaining or the upcoming as well as the past webinars that you can look at that. Thank you for your attention. We have 5 minutes, or if you want to stay longer, for questions. Therefore, I'm happy if there are any. Okay. It doesn't look like that we have questions, but as always, you probably know my email address. I'm happy to answer questions and discuss these things if you say that this doesn't make sense at all, or if you have positive answers and can show me a little bit, point me in direction which I should also look in, or we should look in and harmonize with. That's always very much appreciated. Other than that, if I don't see any questions, I would just close the webinar and wait for you to contact me whenever there is something, or if you want to start annotating your things, then I'm happy to discuss that with you and help you in getting started. And the same is for all the partners in OpenRiskNet as well. Thank you very much for joining, and I'm looking forward to see as many of you on the next webinar on the 27th of May. Bye.